Angles and inclines. Force is at an angle. When a force acts an angle, you can break it into horizontal and vertical components. And you've all seen this before. AX equals A cosine theta, AY equals A sine theta. So if I have some force pulling on an object, I can split it into Fx and Fy using sine and cosine. Alright? Which force will end up accelerating the box is the horizontal one. So if I want to find the acceleration of the box, use Fx equals F cosine theta. Inclines. What is an inclined plane? A tool used to move objects from one height to another, allows for the movement of an object without lifting it directly against gravity. Now, inclines are a bit more complicated. Right? The gravitational force always points straight downwards, but it should be broken into components. And instead of doing x and y components, we're going to do a component that's parallel to the incline and perpendicular to the incline. Alright, so perpendicular to the incline, we have Fg perpendicular equals Fg cosine theta, and parallel, we have Fg parallel is equal to Fg sine theta. So our Fg is broken down into these two components just to make our lives easier. And you can derive either of these using SOHCAHTOA. Alright, the normal force is always perpendicular to the plane. It's going to be equal to Fg perpendicular. And as you can see in this example, it points upwards and to the right. It's always perpendicular from the plane. Alright, if those are the only forces acting on here, you can see that Fg perpendicular and F normal will cancel out, and it will accelerate down the plane where F net is equal to Fg parallel. Or you could have a frictional force. Force of friction, if the force of friction is less than Fg parallel, then it'll accelerate down the plane, and if it's equal to Fg parallel, then either it's not moving or moving with constant speed down the incline. So, summary, Fg points down. The normal force is perpendicular to the plane. If there's no friction, the F net is equal to the Fg parallel, is down the incline. So it's equal to Fg sine theta. So you can remember that, down the incline, use sine. Incline sine, like a road sign. If there's equilibrium, if you're not moving, the opposing force, like force of friction, must be equal to Fg parallel. So if there's friction, we know how to calculate it. Right, sample problem. We have a 900 kilogram car is parked on a 16-degree incline. Find the force of friction. Okay, so this is equilibrium, so the opposing force must match the force that would pull it down the hill. So the force of friction is equal to Fg parallel. So it's equal to Fg sine theta. So Fg is equal to mg, 900 kilograms times 9.8 meters per second squared, times sine theta to get the parallel component, times sine 16 degrees. And your answer is 2,431 newtons.